So, what you've been wondering since we talked about this, how will we find dy dx if we have two separate equations? So this is what you do. Dy dx is calculated by taking dy dt divided by dx dt. Because the dt's will cancel to just dy dx if we look at the fractions. She'll fly in our room again.
Yeah.
Yeah, maybe he just wants to party with us.
He wanted to learn calculus today. Okay. Now, in your homework, you did a little bit of practice finding dx ct and dy dt because you had to look at if they were ever simultaneously zero to determine if it was smooth or not. Is that correct? You guys practice that? Okay.
Are we gonna name the fly?
Good. What would you like to name him?
Fly minutes.
What?
5 minutes.
Leibniz? Oh, I get it now. Okay. I thought you were saying Leibniz, but it's Leibniz.
No.
He's our mascot.
Gabe
He's
is
behind you now.
Gabe is representing us.
Okay, so I think that we are all fully capable of finding a derivative. So we're going to jump straight to let's find the derivative and do something with it. Okay?
I'm not sure if I can find a derivative.
So it looks hard.
Just write it down. And don't get intimidated.
Flights.
I wish I would have
We already
No.
done for like 3 days.
Fruit flies live for a very short time. House flies live a little bit longer, but still not very
2
long.
weeks though.
Yeah, but I could have so much fun in that time. I could fly around.
Fly
Why do flies
around.
exist?
All right, so
Like, what was the purpose
if
of it?
I'm writing a tangent line equation, what are the two things that we need?
Derivatives.
We need a point, and we need our slope. Which one would you like to find first?
Point.
Let's find the point. So if we're at t equals 2, we need to figure out what our xy coordinate is. If we plug 2 in for t, our x would be, and our y would be
6.
Yeah, it's
16 minus 10. Okay, now let's worry about our slope. Okay, dy dx. We calculate by taking dy dt over dx dt. Okay, the derivative of y with respect to t would be
2t.
the derivative of y with respect to t
16
over the derivative of x with respect to t would be 2t. And we would want to evaluate that at t equals 2. Which would give us, oh, a crazy number. I believe. So our tangent line equation would be y minus 6 equals 19/4 times the quantity x minus 5.
Is that all it
It gets complicated when we talk about a second derivative.
Just plug it in.
What? Now, we do have a parametric curve, but a rectangular tangent line. You see what I mean by that? Okay, and that's okay. It's okay to have that. I mean, you can write that parametrically, but don't. So let's talk about horizontal and vertical tangent lines. Okay. So this is our new example, and it will last us this slide and next slide. So if we are talking about a horizontal tangent line, we are looking at when our slope is 0, okay? Well, when we're talking about a parametric derivative, okay, we have a fraction every time, right? Because our derivative will forever be, in a parametric equation, dy dt divided by dx dt. So if I want my slope to be 0, what specifically do we want to be 0? We want dy dt to be 0, okay? So if I ask you for where a horizontal tangent line is, we want dy dt to be 0. So dy dt would be 6t squared minus 24. Which means this occurs at plus or minus 2 for t. But have we answered the question? Find the points where the tangent is horizontal. You found the t values, but I don't see points up there. So we need to actually find those coordinates by doing what? Plugging them into our original x and y. So how about this half of the room? Find us the xy coordinate for t equals 2. So that is 2.
Yep.
This half of the room, find me the x and y coordinate for t equals negative 2. You're getting negative 832. Left half of the room? Yes. 16 negative 32? Sound good? Okay. What do you think the next slide's going to be about? So how am I going to word that? Well, how about this? Here I asked you for a horizontal tangent line. So the next slide I'm going to ask us for a vertical tangent line, which yes means our slope is undefined, so our derivative is undefined. So specifically, if I want dy dx to be undefined, then we want dx dt to be 0. Yes?
We're going to do the same thing in this example, but did you want us to write the values where those points are? Like the values of t where those points are? Is that part of the answer?
Well, it wouldn't be a part of your answer, but it's a part of your work that I need to see.
I just,
Like an XYT coordinate.
yeah.
Yeah, I just need the xy. But I want to see the t's. Okay? So what is dx dt?
2t plus 6.
So I want to see that you solved for t equals -3. Okay. But then your answer is actually the coordinate in which that occurs at.
So is it like one point would be showing t equals -3 and then the other would be.
So you'd probably like get a point for dx dt set equal to 0, a point for finding -3, a point for the coordinate. Okay. Which your coordinate would be at theta 9. I'll just help you. Now, what happens if dy dt and dx dt are simultaneously 0? Okay, it's not smooth, and not smooth means we're going to have some type of like corner, which means it would not be differentiable there. Okay, so if you ever have a time where dx dt and dy dt are both 0, we are not differentiable.
So,
Right.
Why was x -9?
Because we would have 9 minus 18.
I multiplied wrong.
All right, this is how we would find our second derivative.
Why are we finding the second derivative?
for the record, I can't do it. I will be there at 6:30.
6:30. Bright eyed and bushy tailed.
Maybe one of those things. Is that here?
I guess just.
Flysic Newton. Our code word is Flysic Newton.
I thought it was Leibniz.
No, it's the name of the fly. Our code word is
Oh.
Isaac Newton.
I understand. I'm so sorry.
Yeah, it's okay. It was a rookie mistake, but forgive me this time.
Thanks, Joey. Okay, so when we take our second derivative, first of all, it's going to be in terms of t. Already, dy dx will be in terms of t. Okay? So we have to take that derivative in terms of t, but it's still a parametric equation. So following suit to what we did for the first derivative, we have to divide by dx dt.
Can we go like Donnie? I have like 2 minutes.
Sure.
You're getting interviewed. Jesus.
Hey, girl.
What class is this?
This is Calc BC.
Oh man.
Okay? So, my word of advice to you is always make sure that you simplify dy dx before you take the second derivative. Otherwise, you're going to make yourself miserable. Okay? Don't take a quotient rule unless you really have to. Okay? If it can simplify,
I just love deriving.
but remember, you did earn your driver's license and I can revoke them.
Expired.
They expired.
Oh no, did they really?
Yeah.
Oh, so maybe we need to renew them.
And
I sent it in the group chat. Nobody responded. So I just
we
said-
don't- for some reason, group
I just
doesn't
said-
let me know.
It was too hard to respond.
Yeah.
No, I said nobody cares.
It was.
All right.
I saw that.
So our example is this parametric equation set. And we're going to figure out if it's concave up or concave down at a coordinate. Okay? So our first job will be to find the first derivative, so then we can find the second derivative, and then we can determine concavity. Okay? So everyone please find me dy dx and then stop.
He's just living his best life.
That was fast.
They asked who my favorite teacher was.
Are they doing like a survey kind of thing?
It's a senior project in English, so we have to go around and ask people questions.
Oh, you guys are kind of asking the same type of questions?
The group's got to pick them. Some people are going with the generic, like, oh, like, what was your in-school experience like?
Ew. It's a terrible
Okay, and some are focusing on like classes, yeah. Okay, so what did you get for dy dx? Annalie,
I was not there yet.
Yeah.
have you done any of dy dx?
No.
Do you think that you can, on the spot, tell me, enumerate and denominator?
Okay, so 3t squared minus 2t over 2t
So weird.
Okay, is this something that we're going to be able to simplify?
Actually.
Oh, darn it. That's okay.
Big one.
When we take the second derivative, we need to take the derivative of dy dx all over dx dt.
Why does dx dt stay the same?
Well, since we're taking the derivative of a parametric, we have to think about that, like the y and the x, that they're separate. Okay. Let's see. How do I want to write this? Okay. We're taking the derivative with respect to x of the derivative that we just took with respect to x, right? But everything's in terms of t. So since it's dy dx, but everything's in terms of t, we take this derivative, like we're going to take this derivative, but that's basically only accounting for dy squared dt. So we gotta do another x to balance it out.
I'm a seeing kind of person.
Yeah.
So if this is in terms of t, when I take its derivative with respect to x, okay, but it's all in terms of t, I also need to take the derivative of x with respect to t to cancel out the dt's,
Yeah.
essentially.
So, but why don't you take the derivative of the bottom two? Like,
Let's just do it.
yeah,
I'm just gonna take your word
for it, Miss Sumner. I'm confused.
Okay.
You got
So let's get through this one. Let's get through this one. Quotient rule.
Maybe you should revoke our.
Driver's license.
So they're already expired. We'll refuse renewal.
Oh.
No, That's reading. It's called sarcasm.
So what if the 2t minus 2 cancel out? Is that something that
They don't cancel out. Because this would be like multiplying by 1 over 2t minus 2.
No, I know, I meant just in the derivative, not the
Okay, so ask your question again.
Hello, is it okay if I can have Jackson for it?
Can I ask him a question first? Could you repeat your question?
Like, I thought it was when you take the derivative for quotient rule, like sometimes they'll cancel out, sometimes something in the top and the bottom cancels out.
Sometimes.
Is this not one of those things?
Because there's nothing in common to factor out. Do you agree?
How you
So
doing?
they're like, they're not holding hands.
Okay.
They're not holding
How do
hands.
we just start out?
Oh,
Okay. So we would have 2t minus 2 cubed in the denominator.
it's like this all
Oh, that whole thing is.
Because these get squished together.
You can do that.
Because this is like multiplying by 1 over 2t minus 2. Don't pay attention to us, Turning.
It's not. I was just thinking. Sorry, I don't know.
Turner, you're doing great.
Can't do this for the graphical.
You're doing great.
But like,
Keep going.
oh wait, that was
The true probably is a higher rate.
Do you agree with my distribution?
probably.
Do your work, take it with mine.
We should not like.
It's just not pretty when they throw in that second derivative.
Probably.
So this is when we can like leave the derivative on the bottom, or we don't have to FOIL it out on the bottom, right?
No, don't FOIL it out on the bottom. No. 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 So we have 6t squared minus 12t plus 4 all over 2t minus 3 cubed.
3. Where did the 3 come from?
2 minus 2?
This 3?
No,
it should be 2t
right side.
minus 2.
2 minus 2.
2t minus 2, not 2t minus 3. Unless I'm really laughing. Here and here.
Oh, yeah. I think I was just looking forward to writing that 3. That I
makes
just,
sense.
you know,
I also get excited sometimes.
I was excited about that odd number. Okay, what was the point of us finding the second derivative?
Concavity.
We want to know the concavity at the coordinate 0, 4. All right, well, everything's in terms of t because it's a parametric equation.
So that means we have to set x equal to 0. So it's like 2t squared minus 2t equals 0, right? No.
Well, you basically need to figure out which t value is going to make x 0 at the same time that it's making y 4. Yes.
So can you subtract the 4 over and then set them equal to each other?
Sure.
Okay, let's do it.
Or you could play around with numbers in your head
That's
too.
awful though. It's gonna be like not a nice whole. It's not gonna be a whole number, right? There's no way.
2.
Right there. It's not gonna be a whole number. It's not gonna be a whole number. It says
Well, you have 2 options over here, 0 or 2.
Yeah.
Right?
Yeah.
Is it 0? No. Is it 2? Yes. Don't make it too complicated. So,
Get that 0 used.
our second derivative, evaluated at t equals 2, would be
It's a lot of twos. A lot of even numbers.
positive?
Yes.
Because don't we have 24 minus 24 plus 4? All over 2 cubed? So this equals 1/2, which is positive. Come on, Katie.
I feel like that's a lot of work for not very satisfying.
You have like a statistically 50% chance.
But it makes like a smiling face, like
Okay,
yeah, it's a cup. Yeah, it's
so
smiling and
can
it's
you explain to
happy.
me how exactly and why exactly the derivatives of x and y?
What?
Hey, what was that instrument called?
Did you just ask me?
Can you like scroll back up?
I want to say like you could learn a lesson here.
Oh, so you take the derivative of both of them and then you like make the equal 0
What?
all the way at the top.
No, you don't. Because you're given an x, y, and you want to have a t, so you plug in your 0 where your x is and your 4 where your y is, and then you see which t makes both of them work.
So up here, Gabe, like we could say that this is t times t minus 2, excuse me. So I know that our only two options would be 2 and 0. Well, if t equals 0, y would be 0. But if t equals 2, y would be 4, which is what we want. So you could solve one and see which one satisfies the other. Okay? Now, I want to come, because I think I have a good explanation for you if I can just like keep it in my brain. Okay. When we go to take the second, so when we have our derivative and we want to take the next derivative, okay, what happens is we are not in terms of x, so we can't do this. So we have to break this d dx up. We have to take d dt of dy dx, but then that leaves that dx alone. So we have to do dx dt so that the dt's can cancel and you're left with d dx of dy dx.
So we already found dx, so we just keep it the same.
Yes.
I got you. All right.
Every year my mind has to kind of like, it slowly processes that so I can explain it to you. And so I'm sorry that that didn't come before our example, but we got there. Okay. So this is what's going to happen because we have until 51. Oh yeah, we're going to do that tomorrow. Okay, I'm going to give you,
Oh yeah, we have a worksheet, don't we?
tomorrow we have notes in a worksheet that I'm going to give to you at the end. To earn that, I'm going to give each table a different set of parametric equations, and I want you to find the first and second derivative. Please simplify before you take the second derivative. Check it with me.
Is this for today or tomorrow?
This is today's stuff.
Alright, I'm gonna do this without notes.
Yeah, first and second.
Oh.
We have to find the first two.
Yeah.
So
Let's
we
just get to
we're
the
finding
what's
what?
half the problem.
Yes.
Just the first derivative and the second derivative. Like they're equations.